Hello guys, this is Jacob. Today I'm making a video to show you how to use AI to crawl website for free. As you all know, the FireCrawl is a very popular tool to crawl website using AI. They offer free plan for 500 credit, but it's a one-time. So if you want to use more of it, then you have to pay. In this video, I'm going to show you how to use a open source way to build a tool to actually implement the same thing as FireCrawl, but it's open source and free. So that tool is Crawl4AI. So if you search for Crawl4AI on Google, so it should give you a GitHub page. So it's just go to their GitHub page. So this is a fully fledged crawling tool using AI with and without LLM support. So because it's actually using LiteLLM, so it supports majority of the open source LLMs for your website reading and website crawling scraping needs. So that being said, let's get started. So in the GitHub page for Crawl4AI, they have a lot of documentation. And so there are different things that they actually tell you how to install it, how to build it. But I think the easiest way is to use Kaggle.com. And there are a few commands you have to run and to make it work. So that being said, let's go to Kaggle.com. And so all you have to do is first to select if you want to use the GPU or CPU. So in this demo, we're gonna use the GPU. So it's gonna skip a few dependencies installation, but should work as expected. So first, you have to do a apt-get update. So you get some of the update for the Kaggle image. And then if you want to run CPU, run the second line. So the CPU version, they need to install a few things. And because you want to skip the prompt, so you want to specify Debian front end to non-interactive. So because it's notebook, so you don't have to type yes or no during the setup. So if you use GPU, you don't have to run this command. So as you can see, basically it's not needed. So after that, you have to install the pip dependencies. So you just install Crawl4AI and nest async IO and do apply write install. That's all you need to test it out. And let's go to the another sample, which is because if you're running everything on notebook, so you do need to apply nest IO, async IO apply. So this is important. This section is needed if you want to run inside a notebook, including collab. And after all the dependencies set up and also nest async IO applied, then you have to basically write a simple code, which is async web crawler to basically test it out. And the website we're used to test is NBC News Business. So if you go to NBC News Business, this is a website we're actually reading and crawling and do the demoing. So so basically, you just say, okay, I want to read this website, and I want to basically get a markdown version of it. Just 2 lines, and then you just using the async io.run, it will give you a markdown version of the website. This is great, like really awesome. Okay. Uh, One of the other example without LLM is that you can actually not just crawling as a markdown because that's a raw version of the crawling and scraping process. But if you want a more of a structured way to do it, you can use a schema. So if you use the schema and crawl the same website, which is the NBC News business section or category, then you can specify, okay, I want to build a schema as a output of the result. So like if you familiar with jQuery, you can just use a selector. So, and then you can select a HTML class, you can specify a span filter. And then after all this schema is defined, you can just build a JSON CSS extraction strategy. And then with the schema as a parameter. So once you build the extraction strategy, then you can put it in the crawler AROM, async ROM parameters. So that's all you need when you actually do a non-AI crawling. If you want to also build a schema, so that's the way to do it. Then you just simply do extract news teasers, which is the function we defined in here, right? So async function, just run that. You'll basically be able to get the result like that. So the category, the headline, summary, time, and image, because this is actually structured as the defined in the schema, so it will output in this way. And this is all like non-LLM crawling. It's already awesome, right? So next, we're going to talk about how to use LLM, AI-powered LLM to do web crawling. So we're going to demo it in Ollama. You can use Grok, you can use other OpenAI stuff. It's using LiteLLM, so it supports all of the LLMs, almost all of the LLMs, which is great. So to test it in Ollama, you just specify the run command, which is gonna run the bash command within the Python environment. And you basically just do a curl install, install Ollama. Then you basically spin up Ollama just using one line command, Ollama serve. That's it. So you can see that's actually spin up on the GPU, which is we're using in this demo. And you just need to pull any model supported by Llama. So you can pull Llama 3.2, you can pull Q1 2.5 from Alibaba. This is an awesome model, by the way. So which is gonna we're gonna demo in this tutorial. So we're gonna use Q1 2.5 14B, and you can also download like DeepSeek or any other models, or Llama 3.1 or Mistral. So as long as it's supported by Llama, it should be fine. So, and then we run a Llama list. You can see actually we downloaded Q1 2.5, 14B, and Llama 3.2. So all you have to do when you test the crawling using the LLM is to first specify the provider. So we're going to using the Ollama provider, Ollama and Q1 2.5 14B. The API token, you do need to specify, but you can specify whatever you want. So because Ollama doesn't need a API token. So if you do use Grok or use an OpenAI, you do need an API token. So just keep that in mind. So we use Ollama, which is a local service. So we just specify the model we want to use and do an API token. You can also specify the base URL if you want to call a remote Ollama instance or a remote OpenAI or any other self-hosted LLM instance. You can do that as well. So, but in this demo, we can just Ollama is local in the notebook. So, and also specify the extraction type is schema extraction, and we also put instruction here, right? So we want the output to be model name, input fee, output fee. So the URL we want to test, which is the page we want to crawl, is grok.com pricing. You can also use the OpenAI API pricing, which is what Crawl4AI put in the demo. They have a demo for that as well. So you can use this one, but sometimes the OpenAI.com API pricing is not working. Maybe it's due to some anti-crawling or something. So we're going to use a Grok in this case. But either way is fine. You just have to define a URL you want to crawl and then define the strategies, right? Extraction strategy, how you want to scrape it. This is the LLM extraction strategy. So after all that's set up, then you just simply do a crawl.async run. That's all you need. And then the results going to be extracted content. So you can see after you run the command, it's basically the model input fee and output fee from the Grok website, which is in here, right? This is the Grok pricing website. You can just read the website and put it into a structured data in this way. So, which is awesome. This is using Q1 2.5 14B. You can use any other providers as we mentioned earlier. So, hope this is helpful. And that being said, you can also actually just try all the other samples in here, which is like a little bit more complicated web crawling and also data extraction. But that's all for demo purpose. So for maybe education purpose, and you can also specify proxy and local as well. They have a lot of samples. You can also go to Crawl4AI's documentation examples to figure that out. There's a lot of samples here. They also provided a collab notebook. So if you feel free to check that out. It might or might not work exactly, but it definitely will help you to understand how Crawl4AI works. So for that being said, hope this is helpful and hopefully you found this useful and for your project, for your business. Thank you so much. If you like this video, please subscribe, comment, or like it. Um, Thank you so much, and thanks for supporting the channel. See you in the next video.